first piece of the denominator, the second piece of the denominator, and the overall answer. A key to knowing if the whole thing is positive or negative. If there is an odd number of negative pieces, the whole thing is going to be negative. That's true for these guys where it's rational, or the ones we did last week where it was quadratic and they were just being multiplied next to each other. So a tip, odd number of negative pieces. Equals a negative. And that's just because we know this. A negative times a negative, a pair, gives you a positive. So I need a single standalone negative to not pair up with another negative, and it leaves me with a negative. So let's just go through these real quick. We see in the numerator, I did a quick little equation right here, I see that when x is 2/3, that's when I have 0. So that's what I marked right here, 2/3. I checked on either side, and when the numbers are smaller than 2/3 and in the negative, so like 0, -1, -2, -3, the whole thing is positive. But if they are larger than 2/3, 1, 2, 3, 4, that's when it is negative. The first denominator was pretty easy to solve. I see that -3 is where it equals 0. Now, because that's the denominator, I know I'm not actually allowed to use -3 because I can't divide by 0. I check some numbers, and when I am smaller than -3, it is negative. Greater, I am positive. Second piece of the denominator, I see x minus 1 equals 0. I get x equaling 1, gives me 0. Again, I know I can't actually be there because that's going to give me division by 0. Smaller I am negative, greater I am positive. Then it's just a matter of, like you see here, lining everything up. Let me use a different color to show that. So I actually did all of this part first, so I knew what numbers I needed, so I could make my number lines like set up properly, so they were all lined up. So all of the -3's are lined up to get to the final -3. All of the 2/3 are lined up to get to the final 2/3. And all of the 1's are lined up to get to the final 1. So then piece by piece by piece, smaller than -3, I see positive, negative, negative. That's going to give me a positive because these negatives have paired up to become positive. Positive, positive, negative, that one's going to stay negative. Negative, positive, negative, the negatives are going to pair up to give me a positive. Negative, positive, positive, there's that single negative, so I'm going to have a negative overall. And at 2/3 exactly, because I am 0 in the numerator, I will be 0 the whole way through. I'm allowed to be 0 if my answer is 0 and not undefined. So, because of the less than or equal to 0 part of that. So, I want to know, where am I negative? Well, that happens right here and right here. And I'm also allowed to be 0, so negative or 0 exactly. That happens at 2/3. So here's my final answer. I cannot be at -3 because it is an undefined value, but I can get close. I can go all the way up to and including 2/3 because that gives me 0 exactly. Then I jump over to the interval 1 to infinity. I can't be 1, but I can get close, and I go beyond that. So there's my final answer. That's the way that I showed you in class. Now the way that Sam suggested in class is shown over here, which is seeing at first that in this denominator I cannot be -3. I cannot be +1. Those are my two domain restrictions, so I need to consider those. So that's my first thing that I talk about here. These are my domain restrictions. So you just have to worry about those at the end when you make your number line. So then we're going to solve this by first multiplying. Can we see both things? Yeah. By multiplying by the denominator the x plus 3x minus 1 to both sides. When you do that on the left, it just cancels the denominator. When you do it on the right, you have